Hello, I'm Dr. Harper. This video is in Management of Operations BUSN 6630 Section 001, Spring 2021. And this is just going over quiz number 4, the inventory, on just how to approach it and how to set it up. So let's bring up the quiz. In quiz 4, we come down. I will emphasize material in the videos and the website, which will help. And this is just based on mechanics. Homework will go a little bit more into scenarios and applications, but this is looking at just the mechanics of the fundamental relation, the equation to the fundamental equation, ROP and EOQ. Okay, part A. So first of all, I give the same amount of information here. Assume a constant demand of 60 items a week, lead time of 1.3 weeks, safety stock, unit ordering cost, and carrying cost. And then I go through 6 different questions just to get used to moving back and forth between the relationships. And so let's kind of set these up a little bit. And notice each one of these, if the lot size is 30, if the lot size is 30, lot size is 30, lot size is 30, lot size is 30, and then 6 is not. Okay, so I'm giving 30 for each one. So Q is going to be on each one of these. Okay. So this one is, which of the following represents the weekly inventory period? Okay, also notice this is weekly, and let me bold that. This is quarterly. Let me bold that. This is the average inventory period. This is a reorder point. The total annual inventory cost. Let me just bold the annual. Okay. This is average inventory per inventory period. So the time there is inventory period. So let's just bold that. Okay. And the inventory period up here is based on the Q equals 30. Okay, so let's go through and how to set these things up. Okay, first of all, we have Q equals dt. Okay, and that is also equal to d over f. So let's just start with that, and let me just highlight that, bold that, because that's going to be our relationship on each one of these that we will be using. Okay, to set this up, if Q is 30, what's the inventory period? And note this is weekly. Now the demand is in weeks. Okay, so we have 30 here equals the demand is 60 times T. So the idea here is that the demand is in weeks, and the inventory period is in weeks. And so we can use 60 there. This 60 can be used and just solve that equation for T. On this one, the quarterly order frequency, this one, we bring this one down here. Bring this down again. But this time, the Q is 30 equal. Now this time we want a quarterly frequency. Okay, so therefore I have to transform the 60 items a week to a quarter. So I highly recommend when you transform it to a year and then back to what you want. Okay, so we have 60 per week. Transform that to a year times 52. If we're getting 60 a week times 52. Over 52 weeks, that's how much we're going to get over a year. We divide that by 4 to get exactly what the quarter is going to be. So we take the annual divided by 4 to get a quarterly demand. Then we divide that by F and then solve that equation for F. Okay. Next is the lot size is 30, then which the following represents an average, let me do this, average inventory, the average inventory per inventory period. Okay, so again, read the questions very carefully. It is easy to solve the wrong problem if you don't read it carefully. So first of all, let's highlight this. We want average inventory per inventory period. Okay. Well, here Q here is going to equal the lot size, right? And so that Q is going to be the average inventory per inventory period is going to be the 30 over 2. But then we add the safety stock. And the safety stock up here is 7. And so basically that's really all there is to it. It's just understanding over an inventory period, you're going to start with 30 and you're going to go all the way down to 7, then order again. But you're carrying 7 all the time. But then 30, only half of that will be carried because that 30 is going to go away when you receive another one. Okay, so that's really pretty much all there is to that. Let me bold that because that's going to be the answer. On this one, which of the following represents the reorder point? Okay, so now we have the reorder point equals demand times lead time plus safety stock, right? Okay, so now demand times lead time. Well, we have the safety stock up here, which is 7. We have our demand and lead time, but notice our demand is in weeks, our lead time is in weeks. Oh, no problem. So that's simply just going to be our ROP simply will equal the 60, which is per week. Whoops. 60 times the lead time, which is 1.3. There's no transformations because the demand is in weeks and the lead time is in weeks, plus the safety stock, which is 7. Okay? And then which of the following represents the annual inventory cost? Okay, now we're looking at all of this. Okay, so the TIC equals the TOC, which is the frequency times the ordering cost, plus the Q over 2 plus safety stock times the carrying cost. Okay, but we want this over a year, an annual. We want the annual. Okay, and I think people should be able to do this now. Up here we have our frequency. This is going to be quarterly frequency. Okay, so you multiply that by 4 to get the annual frequency. This is the average inventory per inventory period. That's going to be the same average inventory here. Whoops, that should be a plus. This is going to be my average inventory times C sub C. And that C sub C, what is it? Per week, that has to be transformed to a year. So you multiply that by 52. Okay. And then you'd add those two together. Okay. If the unit carrying cost is this, then which of the following represents the economic order quantity? Okay, so now we have EOQ. So remember, EOQ equal the square root of 2 times my demand times my ordering cost divided by my carrying cost. And there that is. Again, we have to make sure we have the right units. So the right units here, the demand is in weeks, the carrying cost is in weeks. So I can use both of them just like that. There's no problem. There's no transformation there. Okay, so then my EOQ then equals the square root of 2 times my demand, which up here, it's way up here, is 60, times my ordering cost, and that's up here somewhere, 40 per order, divided by my carrying cost, that's up here, which is 3, and that's items per week. That's fine, 3. So the numerator is items per week. This is 60 items per week, and this is cost per item per week. So just that arithmetic, you can probably do that in your head. You can do that in your head. 3 into 6 is 2, and 2 times 2, and that's 4. So 2 and 2 is 4. 4 times 4, the square root of 4 is 4. 10 times 10, square root of 10 times 10 is 10. Okay, 4 times 10, you can do it in your head. Anyway, Let's go on. Well, you do everything in your head, but sometimes computers help. Just to verify and validate what you did in your head. I'm pretty sure that's right because it looks right. Feels right. Okay, 7 and 8. Assume a constant demand. Okay, our demand shifts to months. Lead time is in weeks. Safety stock ordering cost is per order. Carrying cost is items per year. If the lot size is 240, then how many of the following statements are true? Now, what I was thinking here is that part A, the demand's in weeks, the lead time's in weeks, the carrying cost, everything is in weeks, okay? But down here, the transformation, I'm easing into the transformation conversion of the different time units, okay? So here my inventory period is in weeks. Here my order frequency is in years. My annual average inventory, it's going to be over a year. And the reorder point, ROP. Okay, so the inventory period, remember the inventory period is going to equal Q over D. Okay, so we got Q, so T equals 240 divided by D. But I want my inventory period in weeks, so my demand has to be in weeks. It's given in months. We transform months to a year, 240 times 12 months in a year times 12 months. That's my annual demand. Then divide that by 52 to get my weekly demand. So there's some conversion in there. Okay, here I want my order frequency is 13 per year. Okay, well again my frequency is going to equal actually 1 over my, I can do this all different ways, 1 over my inventory period, but that inventory period is in weeks. Okay, and if I want that in years, then I wouldn't divide that by 52. Okay, so that's going to equal, well, I guess I could do this a lot of different ways, couldn't I? And just Q over, I could do Q over D. Okay, maybe that's an easier way to do it. Less confusing. Okay, so 240 divided by my demand in years. Well, that's 260 times 12. Because it's my demand up here is in months. Blink. So times 12, it's the annual demand in years. Okay. Okay. Well, the difference between 24 and 26 is, well, this is 3 times 4. Again, you can almost do this in, well, this is 13 times, no, you can't really. This is 13 times, this is 13 times 2 times 10. This is 4 times, anyway, you can do it in your head. Okay, let's go on. The annual average inventory. Well, remember the annual average inventory is Q over 2 plus safety stock. Okay. Bold that. Well, Q is 240 over 2 plus safety stock. Well, the safety stock up there is 2. Well, that one, everyone should get that one. Okay. And then the reorder point is 158. Oops. Our ROP equals demand times lead time plus safety stock equals demand times lead time. Lead time is in weeks. Demand's in months. So we have to transform either weeks to months or months to weeks, or let's transform months to weeks. Okay, so we have 260 per month times 12 is per year, divided by 52 is my demand per week, times the 2.6 weeks plus my safety stock, which, where's it at up there too? Okay, and I'll let you do the arithmetic. not to steal your thunder, and maybe I am stealing your thunder working these for you, but I want everyone. Okay, this next one's interesting. I want everyone to get it right. This next one's and to learn it. It's not getting it right, it's learning it. Okay, which of the following represents the total carrying cost during one lead time? This can be valuable in analysis. Very valuable. Okay, first, probably the best way to do this is the total carrying cost. Here is during one lead time. Okay, first, all of a sudden, let's say, oops, we don't want underline, let's do bold. Okay, what is my average inventory during one lead time? And then what is my carrying cost? I get my average inventory, so it really, the total carrying cost equals the average inventory times the C sub C. Okay, so first let's get our average inventory during one lead time. Remember the lead time, during that lead time, the average inventory is going to be demand times lead time over 2 plus safety stock. Let's bring in the, so where in the world did that come from? Let me show you, for those of you who maybe a little wonder how I got that. Let me come back to my red book here. Let's bring up the lecture for inventory. Here it comes. Okay, let's come down to ROP. EOQ is ROP is up here. Okay, here we go. Now notice during, right here, let's make this bigger. Okay. Can you see it? Okay. So during one lead time right here, we can see, so here, this line right here is my demand times lead time. So that's going to go away. So my D times LT, my demand times lead time, and that right there, over this lead time, that's going to be 1/2 of that is going to be my average inventory. But I carry my safety stock the whole year. So that's not divided by 2. So this is divided by 2, but this is not divided by 2. So this is demand times lead time over 2 plus safety stock. That's my average inventory. Okay, so let's get that out of the way. And that's what it is, demand times lead time over 2 plus safety stock. So that's my average inventory during that lead time. That's how much inventory I have. Now, I want to multiply that by my carrying cost per lead time. Well, my lead time is in weeks. My carrying cost is in years. Okay, so I'm going to take my carrying cost, which is $9 per item per year, and let me divide that by 52, and that's my carrying cost per week. But I want my carrying cost per 2.6 weeks. So I multiply that by 2.6. So I'm taking my average inventory right here. I'm getting my, and this right here, let me double parenthesis that and that. And this right here represents my carrying cost per lead time. In other words, this is my carrying cost per week, and times 2.6 weeks, this is my carrying cost per 2.6 weeks. And so from that, you can bring down the values and just plug and crank, and hopefully the demand, well, not really. Demand is in months, the lead time is in weeks. So let's carry this through. My demand here is 260 times 12 divided by 52. That's my demand per week. Times 2.6 weeks plus over 2 plus my safety stock of 2 up here. See, my safety stock is up here too. So that's my demand per week times 2.6 weeks, my lead time, over 2, plus my safety stock. And then I'm going to multiply by this right here. Anyway, so it's a little bit of, again, it's conversion and making sure you were the average inventory, and so this last question kind of puts 2 or 3 things together. Again, just the mechanics. Now part C down here, let's see, part C, the last 2 questions is just going over the periodic review system and the continuous review system, and we'll see that in the homework. Okay, again, a constant demand rate, lead time, safety stock, ordering cost, carrying cost, etc., and a frequency F equals 2. Which of the following represents the inventory plus for a periodic review system and a continuous review system? Remember, periodic is TQ. And remember, continuous review is ROPQ. So for each one of these, we have to find Q, okay? And so up here, Q equals, I keep having these underlined, there we go. Q equals, let's see, what do we have to work with? We have demand, lead time, order frequency. So let's say D over F. Because we have our quarterly frequency of 2, and this is our demand rate per year. Okay, and so our Q then will be our demand rate per year, which is 1560, divided by the order frequency per year. Well, if we order 2 every quarter, and there's 4 quarters, then there's going to be 8 a year. Okay, well, it'd be 2 times 4. Anyway, there we go. That's going to be the Q in there somewhere. Figure out what that is. Next is the ROP for the continuous review. It's demand times lead time plus safety stock. Whoops. Plus safety stock. Okay. Anyway, we go through it again. I'll let you do that. And there's some conversions that have to be made in there. We've done that above. All I'm doing here is going through it again. I'm going to go through it again. Go through it again, and then find the ROP and which one does it fit 10. Find the T. This is just focusing on the periodic versus continuous review. It's just getting used to that terminology. Okay, and then come over here. The T equals. T is going to equal. Well, it could equal Q over D. It could equal that. Or it could equal 1 over F, because we're given frequency. So the quarterly inventory period is 1/2. But I think we want, down here we want, see here's, we want week for the periodic review. Weeks here, we want weeks. And so we have to go from quarters to weeks if we use 1 over F. Again, going to years, going back to weeks. Times 4 divided by 52 to get my order frequency, my weekly order frequency. Okay, I've given you this. Hopefully everyone, this is enough information. I could work more of it, but I think by now people should be fairly used to this, transforming things around. Now, what I want to highly encourage everyone to do, if we go to Canvas, down here is the inventory, right here. And We started March 9th. We're in the second week. And this video too will be this video. But any questions you have, I highly recommend you go to Q&A. And no one's used it yet, at least for inventory. Maybe everyone knows it already. But if you have any questions, go here. I'm going to start looking at the Q&A because when I answer these questions, those answers are for everyone then. Everyone can go here and see the answers. And if you ask me a question on email and I see it's in this course, I say, post it in Q&A, I'll answer it. Because I think a lot of times an answer to one question, there's more than one student might have that question. And that answer could help more people. So just post it here. And usually if you have a question about the material, there's going to be others have the same question. So any question is fine. And then share information here. Share answers, share information, share spreadsheets, whatever you want. So this is the inventory topic. And so use this to share information. And I'll be using this also. And anything in email, I'll be shifting it here. Now, if you do have questions that you want to have a conversation with me on, I do have office hours Monday, Wednesday, Friday, 7. And a lot of people have been there, which is kind of nice. And that is good too. It's a different kind of help. And I didn't have it last night because we were told everything was shut down. So I didn't have it. Even online was shut down. And so we didn't have it. But this is today. Let's get back here. Here we go. That's all I have for today. I hope this helps with the mechanics. Next time I'm going to start opening up the inventory. And the inventory of the homework inventory, there's where we have scenarios, and there's where we start looking at problems that you would actually see in business. And actually there's some very good problems. And I'm using inventory as a device to say, when you have this kind of problem, here's how you go through it. Okay, and so I'll be doing that in the homework. And then the memo is the communication, and we'll work that even later. So I hope this helps. And if it does help, tell me that it does help, and I keep doing it this way. Otherwise, I'll change and try to keep improving. You never stop improving. That's all I have for tonight. That's all I have for this video. I just want to encourage everyone to stay safe. Between now and the next time I see you, take care.